Hello everyone, this is your Kalpana here. In this video, we are going to do some problems on limits. Okay, so these are the two problems we are going to solve now. So first one, evaluate the left and right hand limits of the function. So they have given function f of x equals to 1 plus x square if 0 is less than or equals to x is less than or equals to 1. That is when x lies between 0 and 1 including 0 and 1. Okay. And f of x equals to 2 minus x if x is greater than 1 at x equals to 1. Also show that limit x tends to 1 f of x does not exist. Okay. Solution. Given f of x equals to 1 plus x square if 0 is less than or equals to x is less than or equals to 1. That means x belongs to closed 0 and 1. Since they have given less than or equal to symbol, equal to is nothing but including 0. And here this equals to is nothing but including this 1. So we have used closed 0 and 1. X belongs to closed 0 and 1. Closed interval 0 and 1. Okay. Now, if f of x equals to 2 minus x if x is greater than 1. Okay. If we consider a real line, suppose this is 1. Okay. So, if x is greater than 1, then f of x equals to 2 minus x. When x is greater than 1, f of x equals to 2 minus x. Good. Now, coming to this. F of x equals to 1 plus x square if x belongs to closed 0 and 1. Okay. So this is the point 1. So this is your 1. Point 1 and this is your 0. Okay. So when x belongs to closed 0 and 1, or you can say it as 0 is less than or equals to x is less than or equals to 1, f of x equals to 1 plus x square. Okay. So now using this, we are going to solve the problem. Okay. So when x is greater than 1, you will consider this function. When x is less than 1, you will consider this function f of x equals to 1 plus x square. Now we will simplify LHL, left hand limit, that is limit x tends to 1 minus f of x. So now we'll replace this limit x tends to 1 minus with or by h tends to 0, and we'll replace this x with 1 minus h. Okay. So this equals to limit h tends to 0 f of 1 minus h. While considering left hand limit, you will consider x less than 1. When x is less than 1, you are having f of x equals to 1 plus x square. Okay. So now we will replace this function. So this is equals to limit h tends to 0. Now replace x by 1 minus h. replace x by 1 minus h here. Then you'll get 1 plus, you have to replace x with 1 minus h. So this equals to limit h tends to 0, 1 plus h square minus 2h. Okay. So this equals to limit h tends to 0. 1 plus 1 is 2 plus h square minus 2h. Okay. Now, putting h equals to 0. Okay. Putting h equals to 0. You'll get 2 plus, in the place of h, replace 0. So 0 square minus 2 into 0. So this equals to 2 plus 0 minus 0. So the answer is 2. Okay. So therefore, limit x tends to 1 minus f of x equals to 2. Good. Now we are going to find right hand limit. So limit h tends to 1 plus f of x. Now replace x tends to 1 plus by h tends to 0 and this x by 1 plus h. Okay. So this equals to limit h tends to 0 f of 1 plus h. Since this is right hand limit, right hand of 1, which is for x greater than 1. When x is greater than 1, we have the function f of x equals to 2 minus x. So now replace x function with 2 minus x. So this equals to limit h tends to 0. Since when x is greater than 1, f of x equals to 2 minus x. That is 2 minus, in the place of x, replace 1 plus h. So this equals to limit h tends to 0, 2 minus 1 minus h, which is equals to limit h tends to 0, 2 minus 1 is 1 minus h. Now putting h equals to 0, you'll get 1 minus 0, which is equals to 1. Okay. So therefore, limit x tends to 1 plus f of x equals to 1. Okay. Good. Now consider the left hand and right hand limits. Limit x tends to 1 minus f of x equals to 2, which is not equals to 1, which is equals to limit x tends to 1 plus f of x. Thus, limit h tends to 1 minus f of x is not equals to limit x tends to 1 plus f of x, because 2, you are having the value of left hand limit 2 and right hand limit 1. 2 is not equals to 1. Okay. So from this we can say that Therefore, if left hand limit and right hand limit are not equal, we say that limit x tends to 1, f of x does not exist. Okay. So the reason behind this is, we know that limit x tends to some c. F of x exists only when limit x tends to c minus f of x equals to limit x tends to c plus f of x equals to limit x tends to c f of x. If these two are equal, then we can say that limit x tends to c f of x exists. Since these two are not equal, so this will not exist. Okay, this completes the first problem. Now coming to the second problem. If f of x equals to x minus mod x by x for x not equals to 0 and 2 for x equals to 0. Show that limit x tends to 0 f of x does not exist. Solution. Given f of x equals to x minus mod x by x for x not equals to 0 and 2 for x equals to 0. Okay. Now consider a real line. Suppose this is 0. When x equals to 0, f of x equals to 2. Okay. When x is not equals to 0, that is when x is less than 0 or when x is greater than 0, we have function f of x equals to x minus mod x by x. Okay, good. Now we'll find left hand and right hand limit. Limit x tends to 0 minus f of x. So this equals to limit h tends to 0 f of 0 minus h. So now replace x in this formula. When x is less than 0, since you are considering left hand limit. Since this is left hand limit, so you'll consider for x less than 0. So when x less than 0, you are having function f of x equals to x minus mod x by x. So limit h tends to 0, x minus mod x by x. Since you are having 0 minus h in the place of x. So I am replacing it with 0 minus h. Okay. So this equals to limit h tends to 0 minus h minus of mod minus h divided by minus h. Since mod minus h equals to h, that is positive. Since you are having mod, any number, positive or negative number in this mod will be always positive. So this equals to limit h tends to 0 minus h minus of that minus h, that is mod minus h is h divided by minus h. So this equals to limit h tends to 0 minus h equals to minus 2h divided by minus h. Minus minus gets cancelled. H gets cancelled. So this is equals to 2. Limit of any constant is that constant. Since 2 is constant here, so you'll get 2. Okay. So therefore, limit x tends to 0 minus f of x equals to 2. So this is your left hand limit. Now we are going to find limit of, right hand limit. So right hand limit is nothing but for x greater than 0. So limit x tends to 0 plus f of x is equals to limit h tends to 0 f of 0 plus h. Okay, when x is greater than 0, again you will have function f of x equals to x minus mod x by x. So this is equals to limit h tends to 0 x, that is 0 plus h, minus mod x, that is mod 0 plus h, divided by x, that is 0 plus h. Okay. So this is equals to limit h tends to 0. 0 plus h is h, minus mod h by h. Since mod h equals to h, so this equals to limit h tends to 0, h minus h by h. Since h minus h is 0, then you'll get limit h tends to 0, 0 by h. 0 by anything is again 0. So this equals to limit h tends to 0 into 0. Limit of any constant is that constant. Since 0 is constant here. So therefore, limit x tends to 0 plus f of x equals to 0. So this is your right hand limit and this is your left hand limit. 2 is not equals to 0. Clearly, limit x tends to 0 minus f of x is not equals to limit x tends to 0 plus f of x. Thus, we can say that limit x tends to 0, f of x does not exist. Okay. So, in this video, we have done 2 problems on limit, saying that limit does not exist. Hope you will understand. If you have any doubts, just leave your comments below. See you in the next video. Until then, bye-bye.